this is the solution to the AP Statistics 2006 problem number 1. When we read through the first paragraph, we see we got two parents who are building these toy catapults at an elementary school fair. They're playing a game. That's for a game. They're going to launch ping pong balls from the catapults down here, launching location. And the balls, if they land within 5 centimeters of this target line, then they will win a prize. So we want the shots to land in the shaded region, right? So all points on the target line are equidistant from launching location. It's basically, an arc. Okay, and if you land in the shaded region, you win a prize. That's what it says down here. Okay, so let's look at the next piece of this. So the parents have constructed the two catapults, and according to two different plans, so they're just different types of catapults or something, and they want to test these before building additional ones. So that's the results down here from the tests. So under identical conditions, the parents launched 40 ping pong balls from each catapult, right? So each of these dots represents the 40 shots, and then you get another 40 down here as your results, right? So for the distances. Now they haven't really said how far the target line is away. They haven't really told us that. So I don't know which one of these is better yet. Like, I don't know if this one, we're going to see in a second, the center is right about 136, and the center of this one's like at 138, right? So I don't know which one is closer to the target line yet. We haven't really gotten that far. I do know that what the results are though, right? And you can see all that stuff. So let's just get to it because I'm not sure where they're going yet until I read it. Okay, so on the first one, part A here, comment on similarities and differences in the two distributions of distances traveled by balls launched from catapult A and catapult B. So when I see similarities and differences, and I see of the distributions, I'm immediately going to the same thing as comparing data, which is the big three: center, shape, and spread. Got to have your center, your median or mean, your shape of it, right? Is it symmetric? Is it skewed to the lower numbers, skewed to the higher numbers? And your spread. What's the range or what's the IQR? And don't forget about unusual features. If you see anything like an outlier, like I see these small and large numbers there, not sure if they're outliers or not, but they might be unusual features. And don't forget about context when you're writing these up. Okay, so for this first one, we need the big three. We need to compare these sets of data. Not necessarily which one's better or worse. That's not what we're doing yet. We're just describing what you see in front of you. Right, so we'll start with the center. If this has 40 dots on it, that means that between the 20 and the 21st dot is your median. So if you count over 20 dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? 20, 21 right in there. That's at 136. So this has a median of 136. Let's take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the 20, 21st is right in there. So that is at 138. So this has a median of 138. Now I'm just writing things on the side for myself. This isn't how I'm writing it up. This is not a good way as your answer. Don't try to cram things in the margin or anything like that either. Okay, so on your separate piece of paper or in a nice area, you need to write this up. Okay, so I would say the median of catapult A is 136, which is 2 centimeters less than the median catapult distance for B. Then we can go into the shape and spread. So let's do shape. On catapult A, actually both catapults are mostly symmetrical. Like there's some on the upper end, there's some on the lower end, and it's kind of unimodal, right? It's got one big peak in the middle. Don't worry about this little peak and this little peak, and don't try to think it's bimodal. It's not. Think of it as a whole. This doesn't really, sometimes you can even draw something over it and be like, you don't really want to do like this sharp little things like that. You just want to make a nice smooth curve over it and say, is that relatively symmetrical or not, right? And in this case, I would say, yes, that's symmetrical. This is symmetrical. So I would just make a quick comment in my write-up about catapult A and catapult B are both fairly symmetrical. And then let's talk about the spread. So usually we do range. Like I can't tell exactly, but this looks like maybe 122 or 123 maybe, right? Up to 155. So that's like 33, 32, something like that for the range, right? Maybe like 32, 33. I'm just writing this to scribble on the side so I don't forget what the numbers are. This looks like 133. Yeah, 133 up to 144. So that's got an 11, right? Of a range, right? So obviously these ranges are much different, and that's what you want to say. So in my write-up, I would say Catapult A has a range of 32, which is about 21 centimeters larger than the range of Catapult B at 11. You can also do the IQR if you want, but it's obvious from the range that it's more spread out. It has more variability, it has more spread. And that's enough. Like just go through the three things, make sure you're using centimeters and catapults for your context. If you want to mention that, we have don't call it an outlier because we don't know it's an outlier, but we have a large value at 155 and we have a small value at about 122, 123 on Catapult A, but we don't know their outliers yet. So you can have that. All right, part B. If the parents want to maximize the probability of having ping pong balls land within the band, which one of the two catapults, A or B, would be better than the other, right? So they want to maximize the probability of having those ping pong balls land in this 5 centimeter zone. So they're kind of leaving out like how far away the center is. I don't know if this target line is 138, then maybe I want to use this one. If the target line was 136, I'd probably want to use this one maybe a little bit more, maybe. But that's not what they're getting at. They're actually getting at the variability of this. They're saying this one, it's so erratic because of the variability and the range that it's not going to hit this small centimeter thing. Like 5 centimeters is pretty small, right? You're talking about a small little zone, right? From 135 to 140, right? You'll only get there. And on this one, you're going to get a lot more, right? Let's say that's the range. I don't know what the real range is, but it's only a 5 centimeter range. So this variability really ruins your chances of getting them on that shaded region. So you would want to use Catapult B because the variability is less than Catapult A. Therefore, a higher proportion of the shots will land in the shaded region. Something like that is what you'd want to say, right? Catapult B is better because of the smaller variability. Now on C, this is where they're getting to the center thing, right? Using the catapult that you chose in part B, so we chose Catapult B, how many centimeters from the target line should this catapult be placed? So now we're getting the option of you can place it as far back as you want or far forward. Oh, well, in that case, I can place it wherever I want. I want to place it right where the median is, most likely, because I want to capture all that data. This is where everything is centered, right? So if it's a 5 centimeter band, I want that target line right in the middle of that 5 centimeters in here. 1, 2, 3, 4, 5, right? So I would really like to capture this and that. That's going to be most of my data points, right? So I want the center of that, 136 to 140, right? 136, 7, 8, 9. 140. So 138 is going to be right in the middle of that, which is your median. So I'd say for Catapult B, which I chose, the median is 138, and also most of the values are centered around 138 in a 5 centimeter kind of range. So that will increase my chances of landing in the target zone for any one particular shot. All right, so that's it for number 1. I'm going to just show the scoring guide real quick and just flash up what they wrote. So if you want to look at it, you'll notice sometimes when they do the write-up of the big 3, they don't put as many numbers as I talk about. I still think it's a really good idea to write as many numbers as you have available to you. Like they give you the median here and here and talk about that, but they don't really give you a number for the range, which I recommend doing. It's there right in front of you. You might as well talk about it. Okay, so there's the big 3 there, and they're using their terminology and stuff. And then part B, Catapult B is best because the distance is very less, right? That's what we talked about. And then the last one, if you use Catapult B, then we should be placing it at 130 centimeters. 138 centimeters. This is the median, and it's a good representation of the center. Like sometimes it's possible the median wouldn't really capture the most, right? Depending on the shape of your graph. But in this case it would. Like they actually calculate it. You see this here. They calculate how many of those 40 shots that it captured. So that's they're not just guessing at it, or they're not just blindly taking the median. They're actually calculating where's the best place to capture most of those data points, right? To get 30 out of 40. So when they were looking here of this grouping in the middle, that's 30 out of 40 of those shots, right? All right. Thank you very much.